when we talk about types such as strings or integers and so forth, it's important to think about the memory in computers, right? Because the idea really in computing is we are storing data into memory and then retrieving it when we need it to do some computations or do whatever we need to do, and then put it back, right, as a result and so forth. So we are manipulating data. So it's important to understand how, at least at a top level, how it all works, so that we know exactly when to use what type versus the other. So types in Kotlin and their sizes. So types, in this case, if you look at a type as a bucket, right, in the memory that will store a certain size of variable, we could divide everything into small types, medium types, large types, and extra large or X large types. What does that mean? Well, first of all, we have to understand what is a bit in computer science jargon, if you will. Now, this is a very computer science topic, and so we're not going to be going into computer science, but I think it's important to understand a little bit what's a bit. Well, a bit in computer science is the smallest unit of data or information, okay? So it's either 1 or 0, on or off. So that is a bit. So if we talk about sizes, obviously we have to have some sort of a default, a central unit that is the base of everything, right? So a bit in computing is the base unit for everything. So that's important because when we talk about types in Kotlin, the basic types are int, byte, and short. And an integer, as we've seen before, we can use it for a whole number. So an int is a whole number, and the int type can hold 32 bits. So that's a lot of data, a lot of information, okay? Now, if we want something that is a little bit smaller, we would use a byte. So if we are working on an application that requires us to have larger numbers, in this case, at least up to 32 bits, then obviously we'll use an integer. But if we know that the application will require smaller numbers, right, that will hold something like 8 bits, then we're going to use a byte. It makes sense. If we want something in the middle, right, not too small, but not too large, then a short would be fine because short will hold 16 bits of information, all right? There's another type in Kotlin called long. Long is a X large type, which means it holds 64 bits. This is really big. It's a large container, if you will, that can hold a lot of information. Now, this topic is very important because you need to understand which sizes or what types you may need in certain situations. Obviously, you're not going to be using long types if you are just creating an application that doesn't really need to store that much in memory. So we've seen int, right? And integer, we saw that is a whole number, and an int type as a whole number holds 32 bits. So it's quite a large bucket, but of course it's not infinite, which means it has a fixed size. So if we want a smaller size type, we would use a byte. So I can say val my byte, for instance, and then I'm going to say this is a byte type. So notice the syntax here, right? There is a byte. And then I could get rid of all of this, of course. In fact, I can come up here and say my byte and give it a value of 120. And then here, of course, I'm going to just go ahead and say my byte. This will make less sense. So I can just get rid of all of this. All right, so if we go ahead and run this, we should obviously see 120. And you can see 120, okay? Now, just to prove to you that there's indeed a limit to this size, what happens if I go to 126? Things are still good. If I say 127, perfectly good. But look what happened if I go to 128. Aha, that's the upper limit. What this is saying is that we no longer can fit 128 into a byte type because that is the upper limit. The upper limit, in fact, is 127, positive or negative. The moment we go over 127, which is the upper limit, right, we get this problem. This shows us that this is not going to work because the byte, it has so much space. Very good. So 127, that is the highest we can go. If I go back here and let's say get another val, and I'm going to use this time my short and say short as a type, it's Kotlin type. Let's see what's going to happen. I'm going to say my short. I'm going to give a value 128. Notice it is no problem. Let's go ahead and call my short here. By the way, because we're not concatenating or interpolating anything, we can just get rid of the double quotes and go like that. That's much easier, more readable. Okay, so let's go ahead and run. 1 to an 8, that's fine. Now, what is the highest threshold here? Let's continue. I'm going to say 29. That seems to be fine. And I keep going, add another number, another number, another number. So at some point, this also breaks. It looks like we have reached our 16-bit size there. This is just to illustrate what I've just spoken about, sizes and types in Kotlin. Now, in most cases, really, all you will always see and use is an integer in most cases in your programming life. But of course, there are times you will see later we can use floats and so forth with doubles. But when it comes to whole numbers, integers is most likely what you're going to be using. All right, so really, you don't have to memorize any of this. It's just an exploration, something that I can let you know about so you actually know, understand it, that there are types in Kotlin. And those types do hold size values, and it's important to be aware of this.